Now let's try to convert the pseudocode that we have written for interpolation searching into programmatic implementation using JavaScript. So let's create a new file called interpolation search.js. In this file, let's create a class called interpolation search, and here let's define a function called interpolation search, and it will basically take the array comma the value that I want to search. Okay, if you remember the pseudocode that we had discussed earlier, right, what we have done, we have defined a variable called start, okay, which will be the starting index in the part of the array that we are searching for the value that user has given. So that will be 0, which is nothing but the smallest index in the array at the beginning. Along with start, we will also define one variable called end, which is nothing but the largest index in the array, that is array dot length minus 1 in the beginning. So these two variables will give us the starting index and ending index, giving the whole array as a search range for us at the beginning. Now what we will do, we will simply define one variable called position, and we will define it with -1. Sorry, I defined it as an int. It's actually let, it is, since it is JavaScript. Now position is -1 we've assigned, right? Later on, when we are actually comparing the values, we will actually find out the position value using the formula that we had discussed, and we will update it with that specific value. Now what we will do is we will run a loop as long as whatever the value in the start is less than or equal to end, and whatever the value that I want to search is greater than whatever the value we have at the start index, that is ARR of start. Also whatever the value that I want to search is less than or equal to the value at the end index. Okay, if at all, if this is the case, we will calculate the position. How? We will simply calculate it with start plus, we will simply do end minus start divided by the value at the end index minus the value at the start index. This value gets multiplied with the value that user has passed subtracted by the value we have at the start index. Okay, but there is a small thing that we need to add. Whatever the division that we have here, right, so far this division could give us the floating point numbers. As a result, the entire position could give us floating point results, since array doesn't support the floating point based searching based on indexing, right? So for that we need to convert this to math.floor of this division. Okay, once whatever the result we get, with that result we will simply multiply it with this value, so and that in that way we will get the whole numbers for the position. Okay, once we get the position, what we need to do, we need to compare the value at that specific index, which is nothing but position. If it is matching with the value that user has passed, that means whatever the position that we have reached, right, this position contains the value that user has passed. So we will simply need to return position. Okay, if this is not the case, there are two scenarios, right? The value at the position index could be greater than the value, or it could be smaller than the value that user wants to search. Based on that, based on the nature of the value at the position, we will either search on the left part of the array or on the right part of the array. So as part of one of the condition, if the value at position index, if it is greater than the value that user has passed, that means whatever the value we got in the position index is greater than the value that user wants to search, that means that search range is on the left part of the array. So how we will search? Just like in the case of binary search, what we have done, we have updated the end to position -1. Okay, if this is not the case, that means whatever the value we have at the position is smaller than the value that user wants to search, that is, it is whatever the value that user wants to search is on the right part of the array. So we will simply update the start to position +1, so that this loop will go and search in the right part of the array. Okay, once we execute this loop completely, right, as long as this condition is matching, now we would have searched all the possible indexes in the array which could contain the value that user has passed. If none of the values are being returned from this logic, means there is no index in the array that has the value that user wants. So in that case we'll simply return -1. Okay, so this is how we actually implement the interpolation searching algorithm. Now let's try to create an object and see if it is actually working according to the requirement that we have. And the array needs to be sorted array, right? So I'm creating array containing 1 to 7 values. Along with that, I'm also defining one value called value, and I'm passing 4 to it. Now let me just define an object for it. Let's say ISS equal to new interpolation search. Okay, now from ISS dot interpolation search, let me pass the array and let me pass the value. In the end it will return the index, right? Let me just store it in index variable and let me just do log it. So console.log of index. Okay, now let's just try executing this. If you observe here, we have defined this file inside the searching folder, right? So to execute it, I'll simply pass node searching interpolation search.js. So I got the output as 3, which is nothing but index 3 that has value 4. Let's say I want to search for the value 7. In that case, if I execute the same thing, I got the output as 6. That means index 6 has the value 7. If I want to search for the value that is not available in the array itself, let's say 17. If I execute it, I should get -1, which I have got. Let's say I want to search for the value which is smaller than smallest value in the array. So I want to pass 17. Okay, if I execute it, I should basically get -1 here too. Okay, if you observe here, which I have got -1. Okay, this is how we actually implement the interpolation searching algorithm in JavaScript. So the main difference between binary searching algorithm and interpolation searching algorithm is only the way we are defining the or dividing the array into two parts, that is either left part or the right part. In the case of binary search, we are dividing it by simply calculating the mid, which is nothing but start plus end divided by 2. But in the case of interpolation search, the mid or the position here is getting calculated by using the formula that you see on the screen. Okay, based on that, we either start searching on the left part of the array or on the right part of the array till we find an index which could contain the value that user wants to search in. Okay, that's all there is for implementing the interpolation search. Okay, thanks for watching. I'll see you in the next one.